All right, good morning, everyone. Once again, welcome to EAA AirVenture Oshkosh 2021. I'm Dick Kupinski from the Media Relations staff. Very happy to have you all here on this sunny Monday, and also very happy to have our friends from Stratos Aircraft here with some exciting developments. We have Carsten Sundin with us today. As you may know his background, he's been involved in composite aircraft design for a better part of 30 years, probably as long as composite aircraft have been in the mainstream, and starting to make it to the core of what we do today in aviation. He was past engineering manager at Landsair, and during that time, I think I remember the Oregon to Norway flight.
I did, yes.
Something to fill a couple hours.
And back.
And back. The important part is going to the moon. You want to come back. Also, engineering manager at Epic Aircraft. And in 2007, he and a group got together and said, well, let's create a new generation of aircraft, more portable, owner-flown personal jets. And a lot has happened since then. Some exciting developments. And as you can see, the Stratos 716X is making its Oshkosh debut here in 2021. So I want to hear all about that. So Carsten Sundin, the microphone is yours. Involved.
Thank you, Dick. Appreciate the introduction. Joining me today is Sean Manhattan, Chief Test Pilot, and Flight Test Engineer, John Smoker. Also with me today is Fred Hadlick, Director of Operations of AI Systems. AI Systems is the first Stratos-approved kit aircraft builder assist center, building a safe and airworthy 400-knot experimental 716 jet will require both the factory and builder assist centers. It's great to be back at Oshkosh after we all missed Oshkosh last year because of COVID. I'd especially like to congratulate Jack Pelton for taking a bold step to make Oshkosh happen this year. We have great news. Our 6-seat 716X experimental aircraft is making its first public appearance this year at Oshkosh. This is a result of all the great feedback that we received from interested customers who first saw the 714 proof of concept aircraft at Oshkosh in 2017. I want to tell you a little bit about the differences between the 714 from the 714 to the 716. The 716 is a considerably bigger aircraft. We added 31 inches in the pressure vessel. We also made the cross-section considerably wider. We added 5 inches to the width, so we have a very large, comfortable cross-section. We also added bigger cabin crew windows, so we even further improved the field of view. So when you're climbing out 6,000 feet a minute on your way to 41,000 feet, you can easily see over the nose to scan for traffic. We also added an air stair door, and we made it possible to remove and replace any passenger seat in less than 1 minute. Our cabin volume increased by 40%, and because the drag pullers of the 716 and 704 are nearly identical, we only lost a few knots of cruise speed. But best of all, we shaved 400 pounds off the empty weight. So we made the aircraft considerably bigger, and we significantly reduced the aircraft empty weight. We brought both the 714 proof of concept aircraft and the 716X experimental jet here to Oshkosh so you can see for yourself the differences. They're on display at our Soar into the Stratosphere exhibit, booths 15 and 16. I hope to see all of you over there later. So the 716X kit build jet is our stepping stone to our upcoming certified Stratos 716. 400 knot single engine turbofan 60 jet that will be FAR Part 23 and EASA CS23 certified. 716 is so named because of its Mach 0.7 cruise speed, single engine turbofan, 6-seat cabin. 716X and 716 share the same dimensions, same cabin volume, same computer refined aerodynamics, and high strength, lightweight carbon fiber airframe design. We're planning on building 10 to 12 experimental jets over the next 3 to 4 years before we pursue with the certification program. And our purpose for producing kits is to help us refine our manufacturing processes, reduce production times, and prepare for building a 716 at full rate production. 716X is powered by a Pratt & Whitney JT15D-5 2,965-pound thrust engine with a 3,600-hour TBO. The 716 with an overhauled JT15D-5 will sell for $2.5 million. First, I'd like to tell you a little bit about why we started Stratos Aircraft 14 years ago. A lot of people would like to upgrade to the safety, speed, smoothness, quiet, and comfort of a jet. But until now, they've been priced out of the market, and we intend to change that. Our goal is to bring to market a new class of considerably more affordable, more economical, and more eco-friendly turbofan aircraft. Simply put, we want to put the cost of owning and operating a turbofan aircraft on par with turboprops. This is not about a one-off experimental airplane. Stratos' long-term goal is to design and build an entire line of the most affordable, most fuel-efficient, and most eco-friendly certified composite jet aircraft, the first being the 716. So we're really focused on building a company. We've made significant infrastructure investments. We have an assembly facility, we have a state-of-the-art composite shop, machine shop, and 2 flight test hangars totaling 49,000 square feet. Again, with the 716, our goal is to refine the manufacturing processes, production efficiencies, and quality controls so we can earn our FAA production certificate right after we earn our FAA type certificate. Production certificate will streamline everyday manufacturing tasks. We chose carbon fiber to build our aircraft for many reasons familiar to EAA members. Vacuum-bagged, heat-cured Tory carbon fiber prepreg structures are well proven and widely accepted by the FAA. Also, outside-in layup of prepreg material in precision molds assures the accuracy that we need to achieve laminar flow over a large portion of the upper wing surface and to reduce fuselage drag. Carbon fiber doesn't corrode, and the fatigue life is virtually unlimited. Your grandchildren, your great-grandchildren, and your great-great-grandchildren may be flying the composite aircraft that we build today. The 716 is primarily a carbon fiber composite aircraft, but we use other materials where that makes sense. As an example, the main gear fitting, wing attach brackets, flap hinges, and many other brackets and fittings are made from high-grade aluminum. We also have a unique feature in this aircraft. We call it the integrated engine mount. This engine mount spans between the pressure vessel and the vertical. Excuse me. You see the engine right in the middle here. The bifurcated intakes go around the pressure vessel, meet the front face of the engine, and this is the exhaust. By removing these non-structural composite panels, we have good access to systems and the engine, and it makes maintenance very easy, including removing and replacing the engine in a single day. We'll be vertically integrated to the greatest extent possible, starting with preliminary development and culminating with customer deliveries. The reason for that is so we can control quality, availability, schedule, and most importantly, cost. As we continue to grow our organization, we're going to continue to grow vertically to include maintenance training, a large parts inventory, and technical support. And we will establish a large network of authorized service centers that will be in place before the first customer takes delivery of a 716 certified aircraft. Let me tell you why we chose Redmond, Oregon as our headquarters. Central Oregon has been a center of excellence for composite aircraft construction for nearly 3 decades. We have a workforce that's skilled, we have proven processes, and the Seattle Aircraft Certification Office is one of the FAA's most knowledgeable and experienced offices for certifying composite aircraft. Examples that you're all aware of includes the 787, the Epic, and the Lancer Columbia series. Airframe manufacturing in Central Oregon not only have created successful kit designs, but also Hard Part 23 certified aircraft such as the Lancer Columbia series and the Epic E1000. Much of our workforce gained their composite experience working for Lancer, Epic, and also Evolution aircraft. Let me take you on a 90-second tour of our facility to show you how far we have come. First up is our engineering office. Every part of this aircraft is designed in CAD, every part in assembly. We use 3D printing for prototyping, and even some of the parts that you'll see on the 716 are 3D printed. Sometimes we even print desktop models like this one. Here we're testing a windshield frame designed to fatigue past the ultimate strength requirements because you just can't afford to have a window blowout at 41,000 feet. I want to tell you a little bit more about our windshield and window design on the aircraft. In the back of the cabin, all the windows are plug type windows. Our windshields are not bonded like a lot of other pressurized composite kit aircraft. They're mechanically fastened, just like the certified aircraft. This is very strong and it allows for easy replacement of the windshields. When we tested our pressure vessel, and our operating pressure for reference is 8.5 psi, but when we tested our pressure vessel to 17.3 psi, our windows passed with flying colors, no problems at all with the transparencies. Our machine shop has 3, 4, and 5 axis CNC machines that help translate our CAD models into precision parts. And we also cut tools on our different machines. We recently got a 5-axis CNC machine from a company in Italy called CMS with a cutting volume like 20 by 10 by 3 feet. Experienced composite technicians precisely cut and carefully line carbon fiber pre-preg into the molds. The molds are then vacuum bagged, rolled into the oven, and cured at high temperature. Our assembly fixtures are cut using the latest generation of 3-axis waterjet cutter with 0.003 of an inch accuracy, assuring a very accurate end result. This is our wing fixture. Highly experienced aircraft welders build the Cabali steel engine mount in-house. And here's the final product. A 6-seat personal jet that can fly coast to coast in less than 7 hours with 1 fuel stop. The Stratos 716X and 716 are entering a very competitive market segment. This is how they stack up against single-engine turboprops. The next few slides all have the same structure. We're showing altitude, speed. This is the turboprop's best cruise speed altitude and their cruise speed. If you take a look at the entry-level turboprop, you can see we're significantly less, and we cruise 50 knots faster than a high-speed turboprop while burning only 5% more fuel. Slowed down to turboprop speeds, and the 716X matches the fuel efficiency of the fastest turboprop because it flies 10,000 feet higher. The upcoming certified 716 will cost just 6% more than an entry-level turboprop, but it cruises 70 knots quicker than the fastest aircraft, which is the middle one here. And it gets even better fuel economy than the 716X. The 716X and the certified 716 compare favorably to light jets as well. The $2.5 million 716X is comparable to other light jets, and it costs about half the average price of its main competitors. A single engine burns less fuel, also saves on direct operating cost. And if we slow down to other light jets, long-range cruise speed, the 716X burns far less fuel than the competition. A low wing loading, strong thrust-to-weight ratio combined with an advanced high-speed laminar flow airfoil designed by Chief Aerodynamicist Dr. Gordon Robinson will enable a 716 to climb directly to 41,000 feet, cruise at 380 knots, and travel as far as 1,350 nautical miles with NBAA IFR reserves. On coast-to-coast westbound trips, the speed advantage over single and turboprop can save as much as 2 hours on that trip. The upcoming certified 716 will cruise 20 knots faster than the experimental 716X, rivaling the speed of the fastest light twin-jet competitors. The $3.5 million certified 716 will be the least expensive in class and also one of the fastest. The 716, the certified 716, will have the same wing loading as the experimental 716X, but even more power to thrust weight ratio. That will allow us to climb directly to 41,000 feet in 19 minutes. The certified 716 will have an engine such as the Pratt & Whitney 535E with about 3,500 pounds of thrust and payday controls. If you take a look at the fuel specifics, our projected fuel specifics for the certified 716 at 0.835 nautical miles per pound at 402 knots, we beat the fuel efficiency even of the fastest turboprop aircraft. First flight is slated for 2026, and we anticipate entry into service in 2028. Now, speed, range, and other performance is great, but not at the expense of cabin comfort. We put together a few slides to show you how our cabin cross-section compared to the turboprop aircraft and also the light business jets. In each of these slides, we're on the left and the competition is on the right. The first one up is the Piper M600. As you can tell, we're considerably larger in cross-section than the Piper M600. This is the TBM 940, also bigger than the 940, and the PC-12. The 716 and 716X are considerably larger than the first two, and it's nearly as big as the PC-12. And we're 90 knots faster than the PC-12. The next few slides, I want to show you how our cabin cross-section compares to light jet competitors. Our cabin cross-section is bigger than the Citation Mustang. It's about equal in cross-section to the Cessna M2, Citation M2. We're also about the same as the Cirrus Vision Jet, which is wider, but the 716 and 716X are taller, making the cabin cross-section about the same. The Embraer Phenom 100 has the largest cabin cross-section in class, including the 716 and 716X, but only by 2 inches in width and 1 inch height. Compared to the Phenom 100E model, the Stratos 716X will cruise 45 knots faster and burn a lot less fuel. Make that a 65 knot speed advantage for the 716 certified jet. 6 floor plans will be offered for 716X and 716. The standard configuration is club seating. All configuration have an aft external baggage compartment, 15 cubic feet aft of the pressure vessel. We also have a few cubic feet up front. This configuration is all forward-facing chairs. I mentioned to you earlier that you can easily remove and replace a seat. You can go from the executive seating to all forward-facing chairs in about 3 minutes. Club seating with a forward lavatory. Side-facing divan with aft cabin forward-facing chairs. And we have a 2-chair executive seating configuration. In this configuration, because we moved the seats a little bit forward, there's a lot more baggage space behind the seats. 50 inches of legroom, and a forward lap. And we have a sports combi, 2+2 seating with 75 cubic feet of internal space for your sports equipment. There's also room in the aft baggage compartment for 2 sets of golf clubs or skis. The 716X flight deck will feature a full suite of standard and optional avionics, including 2 large Garmin G3X screens, dual touch GTN 750 screens, standby attitude indicators, and RVSM equipment. Optional will include a weather radar, Sirius XM satellite radio data link weather, and internet. The certified 716 will have a completely integrated avionics system similar to today's Garmin 3000 with touchscreens, but the next generation. We have 3 14-inch primary displays and 4 touchscreen controls on the lower panel. We plan to offer a full suite of standard avionics, including emergency auto-land systems. Options will include Doppler weather radar, XM satellite radio data link weather, and high-speed internet. We're also looking into airframe parachute systems. Again, the price for the certified 716 will be $3.5 million. The Stratos 716X and 716 raise the bar for owner-flown aircraft because of their speed, high-altitude cruise, range, and jet-grade ride quality. Stepping up to a new high-performance jet has never been so affordable. Never has a jet had such good runway performance. Never has such an airplane been so economical to operate and so gentle on the environment. Thanks for coming today, and please visit us at our Soar into the Stratosphere display, booths 15 and 16, in that direction, about a quick 5-minute walk. And now we welcome your questions. I don't know who's first, go ahead.
So I'm looking at the endorsement series that the accelerator initiative getting involved. Who's your target market in that space, specifically personal jet?
Yeah. I think your question is, who is the target buyers of the 716X, the kit-built version of the 716? Primarily owner-operators. Obviously, they have to be willing to take the time to build an aircraft. It's an extensive commitment. Owner-operators with an extensive amount of experience. All of us are from the kit world, so we have a good feel for who buys these kind of aircraft. I worked for Lancer, I worked for Epic, and I think it will be a very similar demographic.
Certified aircraft? Is that what changed as far as the target market?
Well, once you move into the certified aircraft, then you can do commercial operations, so that changes. I still think the primary buyer is going to be the owner-operator, though, with possibly some air taxi and some other commercial activities. It would make a great ambulance aircraft. I think there's a lot of uses for this airplane. Yeah, yes, sir.
No, you can't give any specific number, but I'd like to get a feel for how expensive graduating 500 series turbofan costs for an OEM. $500 million?
Yeah. That is a great question that I can't answer. Just to be clear, we don't have commercial agreements with Pratt & Whitney yet. Manufacturers of engines, they'd like to see a company like us further ahead before they enter into agreements like that. I was privy to information like that in past jobs 10 years ago, but I suspect it's changed significantly. Go ahead.
The price of your quoting, is that including it or is it?
For the 716X or the certified 716? Okay, so the price I'm quoting, I mentioned $2.5 million for the 716X. That does include an overhauled JT15D-5 engine. Now the kit cost will be a little bit less than that. Our goal is to set the price so that the owner can fly away for 2.5 million. So the kit actually costs a little bit less, but they will need to work with a builder system shop. There will be paint and upholstery. The kit will have all the parts, but it won't include paint, it won't include the upholstery materials. Yes, sir?
Following up on that, are you going to enter into a specific agreement with a specific MRO with regard to providing the engines to you? And what kind of support are you going to provide or arrange for those engines under that?
Yeah. Fred, would you like to take that one?
Hi, Fred Hadley. So we'll be utilizing probably one of the 3 designated overhaul facilities in the country, and that's Standard Aero, Dallas Automotive, and I believe also Covington. We've had work experience with all 3 of those designated overhaul facilities, but we're certainly using one of those groups. Standard Aero, I actually think, just took over Dallas Automotive, so they're actually kind of one and the same company now.
Thank you, Fred. If you guys don't have any other questions, I will be on hand. All of us will be on hand. I'll be here the next couple of days. My colleagues will be all week, and we'll be happy to answer any of your questions. We hope to show you on the aircraft.